This video is going to take you through the last couple of examples that we didn't get to in part 1 of the 7-2 notes. So we skipped number 8 because it was similar to the one that was like before it. So I've got 2 cosecant squared x equals 1 over 1 minus cosine and then 1 over 1 plus cosine. So the right side's definitely more complicated. I'm going to start by trying to narrow that down. To do that, I'll give it a like denominator. So this is going to get multiplied both the top and the bottom by 1 plus cosine. And then same here, 1 minus cosine. So I'd get 1 times 1, which is 1, 1 times cosine, which is cosine. Plus comes from that sign, distribute in here, 1 minus cosine over 1 minus cosine x times 1 plus cosine x. In the numerator, the cosines cancel. I get 2 over, and then if I actually FOIL this out, that's the difference of 2 squares, so it's 1 minus cosine squared x. 1 minus cosine squared x is one of my Pythagorean identities. Sine squared plus cosine squared equals 1. So if I move this over here, sine squared would equal 1 minus cosine squared. So that whole denominator can get replaced with sine squared. And then if I bring this to the top, it's 2 times cosecant squared x, which is what the other side says. Okay, 10, I've got secant squared x minus 1 and then sine squared x minus 1. So again, those have part of our Pythagorean triples. So sine squared plus cosine squared equals 1. If this is 1 minus sine squared minus 1, that means the 1 comes on the side over here, which means the cosine would go to the other side. So this is going to get replaced with negative cosine squared x. And then the first one is tan squared plus 1 equals secant squared. So if this is minus 1, then I get tan squared equals secant squared. So this can get replaced with tan squared x. Tangent is sine squared x over cosine squared x times cosine squared x, well, negative cosine squared x. And then the cosines can cancel. I'd get negative 1 times sine of x, which gives you the negative sine squared x. Left side equals the right side. Okay, we started 12. Well, I showed you an example of what it would look like if it was a cofunction within 12, but really this is where it's at. Tan x plus cotan x equals secant times cosecant. So if I do tangent as sine x over cosine x and cotangent as cosine x over sine x, I need to give them a like denominator to get them to 1. So I'd have to multiply this times cosine and this times sine. I'd end up with sine squared x plus cosine squared x over cosine x times sine x. This is one of my Pythagorean identities, so that becomes 1 over cosine x sine x. And if I move these both to the numerators, they become the reciprocal functions, so secant x and cosecant x. If you look at 13, you've got cotangent times secant. So cotangent can be cosine x over sine x, and then secant 1 over cosine x. These cancel. I get 1 over sine x, which is cosecant x. (14). On the left, I've got a difference, so I would work with that first. 1 over sine x minus sine x. I need to give these a like denominator, so I multiply by sine and sine, and I get 1 minus sine squared x over sine x. Go back to your Pythagorean identity. Sine squared plus cosine squared equals 1. So if I move this over here, 1 minus sine squared would equal cosine squared over sine. If I were to separate out cosine squared, this would be cosine x times cosine x over sine x. And because it's multiplication, either of those can keep that denominator. So I can actually separate out the cosine and then multiply it times cosine over sine, which becomes cotangent. All right, lastly, on this slide, I've got secant x plus tangent x equals cosine over 1 minus sine x. So I'm going to work with the right side because it's kind of how we started the day. And to get rid of this, I can multiply by 1 plus sine of x. Well, not to get rid of it right away, but if I distribute here, I get cosine x plus cosine x sine x. And the denominator becomes 1 minus sine squared x if you were to FOIL it out. So if we went back to sine squared plus cosine squared, sine equals 1. 1 minus sine, so if this goes to the other side, cosine squared would equal 1 minus sine squared. Which means this is cosine squared. So I get cosine x plus cosine x sine x over cosine squared x. And I could have actually left this cosine out as this is because right now there's a cosine on each of these. So if I factored it back out, 1 plus sine x over cosine squared x, this cosine would cancel with one of those cosines. And I get 1 plus sine of x over cosine of x. Now this is split into 2. So if I take what I just got and split it into 2 fractions, they would both get the denominator. 1 over cosine becomes secant, and cosine over sine becomes tangent. All right, 16. So here's something that you could do, which is cross multiply. So sometimes people forget that that's an option. So you can always do that. With this one, I would say see if you can just work one side first. So if I have cotangent squared over 1 plus cosecant, I know cosecant and cotangent are part of the 1 plus cotangent squared equals cosecant squared x. So I would try to get that to one of the trig functions instead of 2 separate ones here because this is the same one over here. So I can rewrite cotangent as it would be cosecant minus 1. And then you can actually factor out that numerator because it's a difference of 2 squares. Cosecant x plus 1, cosecant x minus 1 over 1 plus cosecant x. And then you can cancel through cosecant x plus 1 and 1 plus cosecant x because the order wouldn't matter if it's addition. And I'd end up with cosecant x minus 1. So I'm still not where I need to be, but if I rewrite cosecant as 1 over sine of x minus 1, and I give it a like denominator, it would be sine over sine. And then I can combine it, so it would be 1 minus sine of x over sine of x. And now it equals the other side. Okay, 17 is pretty similar. So if I want to work with that left side, I would do secant and tangent. So tan squared plus 1 equals secant squared. So I'd get 1, move this over here, secant squared x minus 1 over 1 plus secant x. Factor your numerator, secant x plus 1, secant x minus 1 over 1 plus secant x. The 1 plus secants are going to cancel. So secant plus 1 and 1 plus secant, and I get secant x minus 1. Secant becomes 1 over cosine minus 1, which becomes cosine over cosine. And I get 1 minus cosine x over cosine x, which equals the other side. Okay, we did 18. You'd have to factor out that tangent, and so we're at 19. So I get cosecant to the fourth times cotangent x equals, and then it's cosecant squared x, and then times cotangent x plus cotangent squared x. So in keeping with that factoring idea, we can actually take out, so cosecant squared x, a cotangent x on the right, and this becomes 1 plus cotangent squared x. If you go back to your reciprocal identities, 1 plus cotangent squared, or sorry, your Pythagorean identities equals cosecant squared x. So this would be cosecant squared x, cotangent x times cosecant squared x, and then cosecant squared times cosecant squared is cosecant to the fourth x times cotangent x. All right, that sums up what we didn't finish yesterday. So again, I want to stress that these don't always necessarily have to be done the exact same way. If you did them a different way, maybe yours is even more efficient. If you did it a different way, but they still got to the same answer, it's good. And you're going to make sure you submit all your notes to the assignment for today. 7.2, do the whole note, and then use the rest of the time to work on the homework. Have a great weekend, guys, and I will see you Monday.